Hello all, I am Samit Thoser. Today I am going to do a code review on convolution operations. The coding is done on Jupyter Notebook 5.7.1. I have used Tensorflow for performing the convolution. Before starting, I would like to comment a bit on what is convolution. Convolution is essentially blending of two functions into a third function. In terms of coding, let's think of an image as a 2D array of pixels with three channels. I am going to go away from the color aspect and will be dealing in grayscale, that is just one channel. Parameters of convolution include kernel scale, stride, padding, input and output channels. Kernel size I have taken as 3, stride as 1, padding as same, and as already said, channel will be 1. To know more about these, you can check out my video on CNN. Now let's dig into the code. I have imported these modules from into my Jupyter Notebook framework. Then the first stage of the coding will be to get the image from the internet. So this is the link for the image that I have taken from the web. The request command allows us to send a request into an API using Python. The response command will be the response variable will store this image in form of a byte in form of bytes. I have used bytes IO because response.content, the dot content will store data, will have data in terms of bytes. So I have used bytes IO. If I had used response.text, then it would have been string, and it would have been textual data, then I would have used strings. This whole image is then stored in an array using numpy array. I have used img underscore arr as its variable. Then I have used plot imshow image arr to plot the image that I am using. I have used this print command to show the shape of the image. I just run it. As you can see, the image is plotted, and this is the shape of the image, which is a 225 by 225 by 3 image. The 225 is the height, this one the second one is the width, and the third one is the number of channels. The image is of just a Detective Conan. It is my favorite character, uh, just for fun. uh, yeah, so this is a 3 channel image, a colored image. As I told previously, I will be using a grayscale image, so I need to convert this image into a grayscale image. I'm doing this conversion using the RGB to gray command. The imgarr is the picture or the image we have stored, is the place we have stored the image. So I have used this command to convert it to gray shape. I've also printed the gray dot shape to check whether I have actually converted it into a grayscale image. And then I have loaded the dimension of the image into two variables, x and y. X will be storing the height and y will be storing the width. Just run it. As you can see, I get a 225 by 225 image. The 3 is gone because I have converted it into grayscale. Moving on to the next part, that is the kernel size. I have to determine which kernel that I am going to use and what exactly are the convolutional operations that I need to perform. So I am going to perform some major convolution operations like blurring the image, sharpening the image, detecting the edge of an image, and simply putting out the identical image that of the original image. So these are basically the filter values that I need to use. You can easily find these values from the internet. So I'm using this for blurring, this for sharpening, this one for edge detection, and this one for identity. Now, as I said earlier, I'm going to use the TensorFlow command. Like, I'm going to use TensorFlow for doing convolution. Uh, so I have to reshape my image. So my image was in 2D, 225 by 225. I need to convert it into a 4D image, or a 4D array. The first one indicates that to be a batch. The last one is the number of channels, and the middle two will be the dimensions of the image. So x will be the height and the width that I have stored here, and I will use them over here in img 4D. So since I have reshaped the image, initial input image, I also need to reshape my the filters that I have designed. So for the filters, the command goes as filter size, filter height, filter width, number of input channels, and number of output channels. So filter size and filter height will be 3 by 3, as you can see over here, in the identity matrix, or even in the edge detection matrix. Yeah. So filter size will be 3, height will be 3, width will be 3, in number of input and output channels will be 1. Now I will use the graph equal to TF graph command. Graph basically in TensorFlow represents the data flow of the computations, while the session executes the operations in this graph. So what exactly is this? TF underscore input is equal to TF dot variable NP array img4d data type NP float 32. So I am creating a variable called TF underscore input using this TF dot variable command, and the variable that I'm creating will store an numpy array of my reshaped image and of data type float 32. Got it? Similarly, I can store the variables for all the other filters. So TF blur, I'm just changing over here from img4d to img to blur 4d. Then for sharpen, I'll change sharpen over here. For edge detect, I will change edge detect over here, and for identity, I will change the identity over here. So this is how I will create variables for my TensorFlow application. Next stage is to perform the convolution. So command for convolution in TensorFlow is tf.nn.conv2d, and in the brackets we have to specify the input image, the kernel size, the kernel that we are using, the strides, and padding. So as stated previously, I am going to use strides of 1 and padding of same. Same basically means we will pad in such a way that the feature map that we get is of the same size of the original input. You can look into my CNN video for it to understand it in detail. So here tf output 1 will be equal to tf.nn.conv2d, and in the brackets I will specify the input image. Then I will specify what kind of filter that I want to use. Then I will specify the strides, and then I will specify the padding. I will do this for all the 4 filters that I have created. Now what is this fifth one? tf.nn.at_rows_con2d. So this is basically done for dilating an image. Dilating is basically decreasing the intensity of the image. So the intensity rate I have kept it as 1. So I will leave one space between two boxes. uh, Rest all remains the same. We don't need to specify the stride in this command. I have taken the kernel to be the identity kernel. You can use the sharpen, blur, or edge detect, whatever you feel comfortable with. There's no hard and fast rule about it. The last one is the deconv variable. This is basically to show the transpose of convolution or transposed convolution, sometimes wrongly called as deconvolution, but it is being an acceptable term that is being used. This command, basically we need to redo the process of convolution. So tf output 4 is basically the output that I got after convolving the input image with the identity. So if I deconvolve or take the transpose of the output and the identity and the kernel, as I have shown over here, I should get the original image back. For this, I also need to specify the shape of the output. So I know my image size is going to be 1 by x by y by 1, as shown over here. Uh, yeah, the IMG 4D. So these are the five, or these are the convolutions that I have created. Okay, wait a sec, something happened here. Yeah. Now in the session part, I am going to run all these outputs and calculate and create a final image for those outputs that I have found. So the final image is basically tf underscore output one dot eval. So I'm going to use dot eval. So eval basically evaluates the output value of the convolution. Then the next line says final image one square bracket 0 comma colon comma colon comma 0. So basically we need to get rid of the reshaping that we had done earlier. So the 1x y1 that in the IMG4D, that reshaping that we had done, we need to get rid of it. So those ones I have made 0, as shown, as you can see from the code. I will do the same thing for all the output images I want to show, and I have to take 6 outputs, 4 kernels, one for the dilation and the last one for the transposed convolution. I will run this and move on to the next part, that is the final part of this code. Here I am just plotting the graphs or the images. I am using plt.subplots 3,3, so there would be 9 images, like 3 images per row. So since we have 7 images, we'll just see 3, 3 and 1. I've set the figure height to be 10 and the figure width to be 10. I can change it, but 10 seems fine. This AX array is what I have defined, stored the plots, is where I will store the plots. So 0, 0 will be the first position on the top left, then 0, 1, 0 will go down, then 1, 2, 0 will go further down, then 0, 1 will be, so you can just do the I, j for a matrix that we always do. So here I am going to just show the image that I want to show. Okay, so your gray, that is my original name of the image. Then the final image 1, final image 2, final image 3, 4, 5, 6, 7. I've turned off the axis for the last two since they are not going to be there. I'll run the code As you can see, the original image, which was a colored image, now it appears in a grayscale, that is black and white. As you can see, this is the original image. This is the sharpened one. You can see the edges being very sharp. Then the blurred image, which looks perfect. The edge detected image, basically you will just see the edge of the picture, and I think it works really well. Then the identity image, which is the exact same copy. Dilated identity, as you can see, the color has faded a bit. And finally the transposed image, where you get the original image back, and you can see in the transposed one, we have not used the original image anywhere while coding. We have just used the output and the identity kernel to get the original image back. Thank you for the patience. These are the references from where you could learn more about convolutions, types of convolutions. They are really excellent links. You should go and check them out for further understanding. That's it for this video. Thank you for your patience.